All right, number 3. Somebody hollered out number 3. Log base 3 of 1 over 27. So this whole page would be an example of what the non-calculator problems would look like. What I will probably do, your quiz will probably be non-calculator altogether. Then on your test, I'll probably run like a neon yellow sheet or something like that for the non-calculator part. When you turn that in, then you get your calculator and you can finish the rest of the test. So it'll be part calculator, part non-calculator. All right, so look, and I won't give you anything astronomical that you have to do, nothing like with a power that you could figure out on your own. So like for this one, what I'm thinking about is I'm thinking 3 to the what power gives me 1 over 27. So here are the things that go through my mind whenever I'm thinking about this one. I know that because it's going into a fraction, I need to flip something. And the only way to flip something is with a what? Negative exponent. So if I made it a negative exponent, then 3 to the what power would give me 27, the third. So this would be negative 3. And then I go back and check. Is 3 to the negative 3 equal to 1 over 27? Yes. Yes. What else? Let me come on. 18? The last 6, is that what y'all were talking about? Is that where y'all are at the last 6? All right, 16. All right, here's how I think about these. Now, this one was hard because we're thinking about 16 to the what power gives me 8, right? There's not anything, if I took the square root of 16, I would have 4, but I can't raise 4 to any power. This one was a little bit harder because you really had to think about a base manipulation type thing as you came here. In other words, these are both powers of what right now? 2. So if I could get these down to a base of 2, well, 2 times itself, how many times gives you 16? 4. So do we all agree that the fourth root of 16 is 2? How do I say fourth root as an exponent? Over 4, right? Over 4. So that means that this is now 2, and 2 to the what power gives you 8? Third. So if you take 16 and you raise it to the 3/4, that means the fourth root of 16, and then raise it to the third power, which is 2 to the third, which gives you 8. This one was hard. This one was hard. Okay, what if I asked you, come back to this one, hold on just a second. What if I said, what would you tell me that one equals? 16 to the what power gives you 4? 1/2. Why 1/2, Emily? Exactly. This would be 1/2 because 16 to the 1/2 is the same thing as the square root of 16, which is 4. So you got to go back when we learn those roots and rational exponents and remember those so that you can do it here. Let me give you another one. Log base, let's see. That's exactly right. Y. 64 to the what power gives you 4? Well, the only way to make it smaller like that, but not in a fraction, is I'm going to have to take a root, right? What root could you take to get back to 4? Yes or no? What? Yes, Charlie? Really? No, somebody said no. No. If you're going from a big number to a smaller number, but fractions are not involved, in other words, I'm not flipping anything, okay? If this was log base 4 of 1/4, I know I need to flip. I'm not doing any type of flipping. I'm just going from a big number to a small number. I need to think about roots. How can I get that down to a smaller number? I need to take a specific root of it. Well, how does 64 and 4 relate to each other? And I think this was the way Emery was thinking about it, is she said, well, 4 to the third is 64, so I would need to flip that around to come over here and raise it to the 1/3. Let's do another one because I'm getting points there. Everybody's going, oh my gosh, yeah. Can I do that one? Oh, yes. So 4 to the what power gives me 1/4. I just need to flip it around. So I just do a -1. Not quite this different, but yeah, some of these where you'll have to, yours you're having to change the base to. You can use your calculator to find, like if you don't know what 4 to the third is, what I'm trying to get you away from doing is taking out your calculator and doing a change of base, like what I'm going to show you today. And I'll show you why. Eighteen's 18 you can't do without a calculator. 21 you can't do without a calculator. 20 you can't without a, yeah. All right. So 16, so I'm saying what do I need to raise 16 to in order to get 8? Well, there's not a perfect root of 16 that would give me 8, do you agree? But there is a base that I can manipulate both of them to have. In other words, 2 to the 2, 4, 8, 6. 2 to the fourth is 16, and 2 to the third is 8. Do you agree with that? So maybe this might help you more. Write them that way. Write 2 to the fourth. Raising that to what power will give you 2 to the third? That does not help. How does that help you? What's the answer? That helped you. Well, if this is a question mark, if you've got 4, we'll call it x. This is x equals 3. Then divide both sides by 4. Nah. Yeah. Yeah. So 15 doesn't have a base indicated, which means the base is what? 10. So it's asking 10 to the what power is 1,000. And it would be. If you cannot get 16 and 17, I am okay with that. 18 through 21, you really need a calculator for. Yeah. And I'm going to do it, but if you can't do it, it's okay. All right? So y'all don't freak out on me. If you need a calculator for 17, that's okay. I just recognize right off both of these are powers of 3. Right? And maybe you don't because you haven't worked with powers bigger than like to the fourth power very often. I just know that they are. So you're asking 243 to the what power gives you 27. So I probably would manipulate these bases to get a base of 3. 3 to the what is 243. 3 to the what is 27. So what's the exponent that you need? 3/5. Yeah. Yes. Again, if you can't get these, that's okay. I'm not so worried about that. Be proficient up through 15 though. 13, log base 18 of 1. So 18 to the what power gives you 1? That's one of your properties. What can you? 0. 0. Anything to the 0 power is always 1. No, skip those. It's fine. Say again. Because you're going from a whole number to a fraction, yes, you know it's negative. Take out your calculator for just a second. I'm going to show you how I want you to do 16 through 21. Just these, though. Yeah. My calculators are gone right now for AP testing. I'm sorry. Actually, I have one right here. All right. I would write this somewhere in your notes because this is pretty important. What? Yeah, that's what we're. Yes. Yes. All right. This is what we call change of base. These are for strictly calculator problems only. It's not for the non-calculator problems, okay? So when we have a log that we cannot evaluate, something like, let's go with number 18, log base 3 of 92. There's not an exact exponent I can raise 3 to get 92. And I can't put in my calculator anything other than a base of 10, right? Because it doesn't, that's what the calculator reads in. Well, we can do this change of base, and what the change of base says is that you can rewrite any logarithm using any base you want as long as you do the same one both times we're dividing. And so to put this in your calculator, you would do the log of 92 divided by the log of 3. So you do the number that's written big divided by the number that's written teeny. I don't like to say big number and small number because sometimes you've seen the base can be bigger than the actual number. So in formula, it would look this way. And it's called change of base because I could put any base that I wanted to here. Okay, I could say this is log base 2 of 92 over log base 2 of 3. It doesn't matter the base, but because your calculator's in base 10, it makes sense to put it in base 10. So take out your calculator and do log 92 divided by log 3 and tell me what you get. These won't be exact fractions. You'll just have to leave the decimal. 2 decimal places. Uh-oh. Yeah. That's right. 0.11. It could be any log. That's the thing I was getting to. It could be log base 15 of 92. As long as that base is the same thing. What I'm saying is this is what it started with. As long as you do the same base, top and bottom, you're changing this base. That's why it's called change of base. Okay. How about it could be any base you wanted. Change of base works for any base, but we use base 10 because that's what our calculator said. How about 17? We already worked 17. So let's see if we got the right answer. So it's log base 243 of 27. Do that on your calculator and tell me what you get. 3/5. Is that what we got when we worked it? Yes. Yes or no on the change of base? What's wrong? Bless you. What else on your homework? Bless you. Is it the scent in here that's making you sneeze? Do I need to cut it off? Okay. Which one? Somebody said 1. 19. 19, same thing on your calculator. So log base 7 of 35. Do log 35 divided by log 7. Tell me what you get. This one will be a decimal. There's nothing you can raise. It should be between 2 and 3. I mean 1 and 2 because 7 to the first is 7 and 7 to the second. 1.82. All right, you got a graphic organizer in front of you for properties of logs, so here we go. You should know those first two things already. Oh, well, maybe you don't. You know the second one. But basic rules as we go through this. The log, if the base is the same thing as this number, this should make sense to you. What do you think that equals? 1. It has to equal 1. B to the what power is B? 1. So if you look at that first example, the log base 14 of 14 would have to equal 1. Now just to piggyback on that just a little bit, if there's an exponent here, and if you want to write this under, you're certainly welcome to. The log base b of b to a variable, to an exponent x here, would be x. In other words, if this was log base 14 of 14 to the third, what would that equal? 3. They essentially just cancel each other out, okay? And then the second basic rule there says the log base b of 1, what does that always equal? 0. And we just did that one. That is because anything to the 0 power is always 1. It doesn't matter what it is as long as it's not 0 itself. So log base 3 of 1 would of course be 0. Okay, y'all ready for the good stuff? It's not hard, it's just all right. I'm going to show you these 3 rules. Bruh, where have you been? We haven't done anything yet. Like, we just started. And you already lost track? Huh? We're expanding and condensing today. Unfortunately, it's a big thing. Logs are big. All right, let me get through them so that you understand what it is and how to do it. All right, the first one is the product rule, and I don't care that you know the names of them. It's just there for the organization of it. But you do have to know what they do. So remember, logs are what? Exponents. If you remember that and you know your exponent properties, it makes this a little easier. So if I have this log with a base of b and I am multiplying inside this parentheses that are hooked to this log, I can separate that out. Now if you multiply something with the same base, what do you do with the exponents? You add them. So I can split this up, log base b of m plus log base b of n. If I split it up and make it bigger, this is called expanding. So if I start on the left and I end up on the right, that's an expanding. So if it says expand the following logarithm, that's what we're doing. However, it could be that I started the one on the right, I recognize that they both have the same basis and I'm adding, and I end up at the one on the left. That is called condensing. So if I start over here and move this way, that is called condensing. So you've got two little examples there. Log base 5 of 6 plus log base 5 of 7, and it says to condense. So if I condense, I'm making it smaller, I'm smushing it together, what do I do? So it's log base 5 of 42. No. All right, look, if I'm multiplying here, then I split them and add them. So if I'm adding them here, I would put them together with multiplication. Yeah. You won't be able to combine them. You only combine the ones with like bases. Yeah. This is the property. It's kind of like, remember if we had like x squared times x to the third, I added the exponents. It's just a property like that. That's just what we do. All right, so the next one, yes. So the next one says the log base 2 of 63, and it says to expand it. So what two numbers can you think multiply to 63? 7 and 9, 9 and 7. So, or 3 and 21, or anything you want. But what I do is I'd say, okay, 9 times 7 is 63, right? So this is really like log base 2. How could I split that up? That's right. The first example is an example of condensing. You condense and you only write log one time. If you only have log written one time in your answer, it's completely condensed. If you have multiple logs, then you're looking at an expanded problem. Everybody okay on product rules so far? Two more to go. And we'll go through some examples so you can do your homework. Huh? Well, change your base at the very bottom we've already done. We talked about that in the beginning. So two more. All right, so look at the second one, the quotient rule. Going back to what you know about exponents. Charlie, if I divide with the same base, what do I do with the exponent? If you have x to the fifth over x to the third, what is one? I'm not talking about logs. I'm talking about back. Rewind back. If you divide with the same base, what do you do with the exponent? You subtract them. In other words, if I had x to the fifth over x to the third, I would subtract 5 and 3, right? Same thing here. Since logs are exponents, it's the same thing because I am dividing. I split it with subtraction. So log base b of m minus log base b of n. From left to right, what do you think that's called? Expanding. From right to left, condensing. Looking at the example there, it says to condense log base 4 of 84 minus log base 4 of 12. So what do you do? Divide them. 84 divided by 12. Come on, y'all should know that. 7. You leave it as the fraction. Most of these, most of the time we're going to be working with variables, not numbers like this. And so you'll just leave them divided, but yeah, you just leave it as fraction. How about expand? And this one looks a little funny because something's missing on this one. What's missing? The base, which means it's 10. So it's not missing, it's there, it's just not written. How could I expand that out? You said, say it again? Absolutely. 81 divided by 9 is 9. That would definitely work. 27 and 3. Anything you want to do? We aren't changing the base. We're expanding. We're what? Go ahead, tell them again. Okay. What can you divide by each other to equal 9? And so, Caden said 81 over 9. You do 27 over 3. You could do anything that equals 9. 63 over 7. Any of those would work. Those are the two easiest. We've already done change of base. Power rule is probably the easiest one that we have. If you think about it, a log is an exponent, right? What happens when you raise an exponent to another exponent? What do? You multiply them, right? So this is an exponent to an exponent, so I multiply. So what happens, this one's kind of fun. This exponent comes around to the front and multiplies. It just, whoop, comes out in front. From left to right is expanding, and of course, from right to left is condensing. So the first one says condense 2 log base 3 of 8. What would that look like? A to the second or 64, either one of those would work, right? The expanding one looks a little worse, but at the end of the day, it's really not because it's just the right type of thing. What would that look like expanded? The x minus 1 jumps around to the front, right, and gets multiplied. So I'm going to put the x minus 1 out front. I'm going to put it in parentheses since there's more than one part to it, just so that I know all that goes together and gets multiplied to the log base 2. Tell me what you think about the properties. Those are the 3 properties we're going to be using to expand and condense. 8 to the second. Yes, we'll do several of them. We'll do some. I just knew 8 squared was 64. It doesn't matter though, either one would work. It's whatever this number was here, it came around as the exponent. All right, let's put it all together and do some examples. Are y'all ready? Bless you. We'll start with condensing. I will tell you with condensing, I always go, you need to go order of operations, so make sure you do any parentheses first. Always take care of parentheses, exponents, and then my addition subtraction the same way order of operations goes. So let's look at it. We've got 2 log 6. I'm missing a base. What does that mean? 10. That's exactly right. See if you can condense that down to a single logarithm. Don't blur the answer out whenever you get it. I'm going to let you try it and we'll do it together. What did you do first? Exponents. There's no parentheses, so move on to exponents. I got log 6 to the second is 36. Now what? Divide. Subtracting means to divide, right? So I'm going to do 36 divided by 9, which is 4. Something like this will be non-calculated. You just have to remember what each thing does. Let's make it a little bit harder. Remember addition, subtraction, left to right, okay, as it comes. You'll see why I said that. Condense this expression. Golly. What did you do first? So now I have log base 3 of 4 plus log base 3 of y plus log base 3 of 7. What now? Y what? 49 to the 1/2. So be careful, because if there was subtraction sprinkled in here, I would have to go left to right in order. Since multiplication is commutative, I can do it in any order. So I can multiply 4 times y times 7. If this had been a minus, I would need to be really careful about my order and just do 2 at a time left to right. But yes, this would be log base 3. 4 times y times 7 would be 28y. It's an operation. It's actually, and if we have time, we'll try to do the project. I don't know if we'll have time. Um, the earthquake, you know, the Richter scale for earthquakes. The Richter scale is a logarithmic scale. Isn't that cool? It was especially cool because we were having all those earthquakes, so we did some. I used to have them hanging up around. There's a couple. Uno mas, and then we'll do some condensing. We don't use this log a whole lot. We more use the natural log, and we will get to that probably Monday. Yeah, this is going to all of these. I did parentheses first if I was doing this. But you'd probably need a calculator for this one. Do I? If you would like to do that first, you can. If you would like to combine inside the parentheses first and then do the outside, you can do that as well. It's up to you. Would you get, Wyatt? Well, if you see it, what's the third root of 8? The third root of 27 multiplied together. Divided by 3. Did you? 25 times 8 is easy, and then you add 2 back in 8 times. That's how I do it. Do you do it? Do you see it in your head doing like regular long? That's that Common Core math y'all all complained about, but really, if you've learned it, very helpful. Whenever y'all were in like second, third grade, and they were trying to teach you if you multiply this to do what you can do, like what he just said. He said he did 20 times 8 because you can do that in your head. 7 times 8 you can do it in your head, and then you can add them together. That's what they tried to get you doing. I see 25, so I do 25 times 8, and then 2 times 8. But well, you can, but if you needed to do mental, it's just Common Core was more about mental math than it was. Okay. All right. Anyways, back to this one. I would have, if I were doing this one, because I recognize, I know that multiplying by 1/3 means I'm going to have to take a third root somewhere. And I know that this can distribute through since I'm just adding inside there. I did the third root of 8 and the third root of 27 because I know both of those are easy to work. You don't have to do it that way. They're just like with properties of exponents, as long as you follow property rules. Um, but how did y'all do it? Because I'll do it the way y'all did it. 8 times 27. All right, so I got a third times log base 5 of what? Now the 1/3 comes around. What root? What's the third root of 216? What times itself 3 times gives you 216? 6. Now, because I'm subtracting, I divide these two bases, and I get log base 5. Students hate logs, so I'm sorry. Yeah. This, I wouldn't give you numbers that big without a calculator. Yeah. Y'all ready to expand one? Haha. I mean, I don't have, if you know how to do it, I don't mind stopping. I can at least go and pass around homework while y'all. All right, expand. Now this is opposite of condensing, and that exponent is only hooked to the z. It's not hooked to everything. It's only hooked to z. So be careful as you pull this apart. It's only going with z. So this is not the same as this. What you think? What shall I do? This is an easy one. Split up the multiplication? Atom. That's right. This isn't a change of base. You're not evaluating your expanding. Change of base is for evaluating. Telling what it equals. Is there anything else that I can do? Put the 4 in front. If there are variables in there, you're not going to be able to solve it. So now I've got log base 6 of x, and you didn't have to take 2 steps to do this. You could have seen this in one, I'm sure. But just for the sake of example, sorry for nothing. No, that's the most you can do. Expand. I'll tell you. Expand the following. Condense the following. No. No clue. I hear no clue. I gotta do something first though. But yes, I will be adding them. No. Change what form? Not yet. This is this. A square root is an exponent of 1/2. I need to put it in exponential form. Now, what? 2 ways I could go about this. Huh? That's not a rule. That's what we learned with rational exponents, is that any root can be written as an exponent. If you see a root, you need to write it as an exponent. All right, so a couple ways, and let me work it both ways and show you in whichever way you prefer. If I'm working this one, I'm probably pulling that 1/2 around front now and having 1/2 log 7x cubed. And now I split up the 7x cubed. The problem with splitting up the 7x cubed is this 1/2 is going to go to both of these pieces as I split it up. And I'm going to go ahead and put that 3 in front. That's way number 1 you could work it. Way number 2 you could work it is if you took this, and this only works, I'm hesitant to do it because it only works because I am multiplying inside the parentheses, not adding or subtracting. I could take that to both and say, well, that's the same thing as 7 to the 1/2, x to the 3/2. Now I could split them up. So log base 7 to the 1/2 plus log of x to the 3/2, and I could bring those around front. 1/2 log 7 plus 3/2 log. No, you don't like it, or no, you don't understand it. But either one's fine. Because look, these are both the same thing. If I distributed this 1/2 through, so either one's fine. They both bring you to the right answer. Yes. Clearly, y'all do not like expanding first. Which one's easier, expanding or condensing? Shall we do another, or do you want me to let you loose on your homework? Another? Let's do one more. Want a radical one? If you got it and you understand, feel free to go ahead and start on your homework. If you want to watch this one, feel free to watch this one. Because there's a radical, I need to change that to an exponent. What's the exponent? 1/4. That's exactly right. So log base 3, so I've got m5 n2, all of this to the 1/4. Now again, two ways to do it. I could take it to both of these, or I could go ahead and bring it around front. What? Yes. That's that property. It log. Yeah. So is the property. This is not this. This is this. So what do y'all want to do? You want to take the 1/4 around front now, or do you want to distribute it inside first? Okay. So 1/4 log base 3 m5 n4. What now? Wyatt scared y'all was gonna jump on him if he says it, so he just mouths it. What? Oh, yeah, sorry. So what do I do? Split it up with what? M to the 5th, and then what do I put in the middle here? Plus, because multiplying means add. Log 3 n2. Can I do anything else? I got to take care of those exponents, right? That's exactly right. 5 log base 3 of m plus 2 log base 3 of m. Does that make sense? Logs get sticky. The other way, I would have said that this was log base 3, taking this to both pieces. So m to the 5/4, n to the 2/4, which is a half, right? Then I would have split it up, log base 3, m to the 5/4 plus log base 3, n to the 1/2. And now each one comes around front. 5/4 log base 3 of m plus 1/2 log base 3. Yes. As long as you're not adding or subtracting in those parentheses, yes. Yes, both of them are. I